Hi, Drew. I'm going to try to answer your questions on 4.2, number 22. You emailed me this morning. We're getting a new roof at our house, so I apologize for the loud noises. Hope you'll be able to hear me through them. There's a lot going on with this 22 and 23. I'm going to go over 22 in detail, and 23 is just a slight change. In this problem, we're looking at control group, people do not play football, and then football players that did not have diagnosed concussions. And group 1 is a control group, never played football. Group 2 is the football players. So in this case, again, if you can make this work, great. Don't worry about this box too much. But the null hypothesis is that mu1 equals mu2. The alternative is we're looking at, is there evidence that the average brain size of people who've never played football is larger? So does playing football decrease your brain size? So group 1 is greater than group 2. Okay, you stack here the technology to find the value of the relevant sample statistic. X bar 1 minus X bar 2. So I could download and upload the data into StatKey, but actually this data set's already pre-uploaded. So if you go to StatKey, we're at randomization hypothesis test, difference in means. If you go up here, let's make this a little easier to see. If you go up here, there's some preloaded data packages. It's brain size, control versus football, no concussion. So I'm going to click on that. And notice right here, it gives the sample mean difference of 1143.4. So that is the answer for the statistic, 1143.4. P-value is going to be 0. So how do we get the p-value? Generate a couple thousand samples. Because the null alternative hypothesis is greater than, we're looking at a right tail test. And I need to enter my sample statistic, which is 1143.4. Click OK. And p-value is 0. So it's not 100% 0, but it's very, very unlikely to happen. So that's why p-value down here is 0. For part D, does it appear that this difference in brain size is due to random chance? That'd be no, because that p-value is so close to 0. We would reject the null hypothesis with this small p-value. It appears to be that there's some effect with playing football and brain size. So the only difference between 22 and number 23, you go through the same thing, but you're looking at football players without diagnosed concussions versus football players with concussions. So all you have to do on the randomization test for difference of means, go through the same exact thing, but we're going to change football, brain size football versus concussion versus no concussion. So notice right here, if we generate a couple thousand samples, now if I do right tail, 724.6, if I enter in the difference, there's a larger p-value, it's still pretty small. This is going to be another reject the null hypothesis. Okay, I hope this helps and you're able to hear me.